If you've ever looked at a few different electrical panels, especially if you've opened some, you've probably noticed one thing. No two look the same. Different brands, different layouts, different ways of connecting the breakers, extra devices you've never seen before, contactors, relays, timers, surge protection, smart modules, sockets, dead mouse, a note from the previous owner. Every panel looks different. So how are you supposed to know what you're looking at? The good news is that underneath all different looking parts, the wiring principles are almost always the same. In the previous video, we learned those principles by wiring a simple single-phase panel from scratch. At its core, every residential panel has two main jobs: distribution and protection. Distribution means taking power from one supply cable and distributing it safely to the outgoing circuits. Protection means placing breakers and RCDs between that supply cable and those circuits to protect the wiring and people from electrical faults. But understanding the principle is only the first step. The real challenge comes when you open a different panel and none of the equipment looks the same. Take these RCDs for example. So same thing as this one. They're all French made, yet every one of them connects a little differently. So even within the same country you can come across very different equipment. Even if you were wiring these exact same 5 circuits, you'd probably be using different hardware. So today we'll gradually modify this panel, changing one piece of equipment at a time to show you different ways of distributing power. Different hardware, same principle, so let's get started. Alright, let's start with the simplest thing, replacing this RCD for this one. Same brand, almost identical. This is your input side where the supply cable goes, an output side that goes to the breakers. Same as on this one, except that this one doesn't have classical screw terminals. It can be connected only with a comb. That's not a problem on the output side, because you connect it with the comb anyway. But on the input side you can't just push a thick wire in and screw it, because these holes are too small. You can connect it only with a vertical comb if you have several rows, or a special connector. I'll show you. By the way, the power is off, and always turn the power off when you work on a fuse board or any electrical equipment. I need to unscrew all of these in order to remove combs, in order to remove an RCD. Now these wires, they can't go in like this. They're too thick. And these are 10mm square, you have even thicker wire, 16mm square. Now I fix this connector. Fix it to the RCD, screw it. Put the combs back. This one here, you just stab it in. And yes, you also have circuit breakers with automatic terminals. So you will just push them in without screwing, no screws. Like this one here. Okay, so that was easy. You also have RCDs where the input is at the bottom and the output is at the top. This one has screw terminals at the input, luckily, and automatic COM terminals at the top. Well, I'm not gonna bother with shorting the wires now. This is live output connection on an RCD. I can use the same comb with the same length. But here, because my neutral output is here, this comb is going to be too short. Because it's a different model, the holes are slightly misaligned. So we would need to use special connectors. Connectors. But normally if you use these brands, Hager, RCD, you would use circuit breakers of the same brand and they have a special comb. What we can do, we can use this kind of connector, but you stab it here in an RCD. You put your comb back here. Now the comb is too long on this side. You can cut it and then you use a short piece of wire, but of wire of the same diameter as your input wire. It can be smaller. Between the RCD's output and breaker's input for the neutral. But in many countries, in many installations, neutrals don't go through breakers anyway. They all connect on one bus bar and you connect your RCD's output neutral to that bus bar. Here they go through the breakers. Oh, this is complicated. And yes, you would rarely do this kind of improvisation. It's not very neat, but it's legal. Sometimes you will need to replace a defunct RCD with a new one, and you don't want to replace all the breakers. On this RCD, the input is at the top, the output is at the bottom. So it's a top-fed RCD. How do we know? Top and bottom look identical, and there's no markings. Well, this is an indicator. These two things at the top, they represent your input. Neutral to the left. That's how it's done in France, even if it's not specified here. Now we connect again our breakers inputs with combs, live and neutral. They're too long now because they don't connect to the RCD, just like with Hager model. But I have shorter ones here. So, neutrals. And now we need to connect this to this. Neutral, live. I have two possibilities with wires. Let's do that first. Long enough. Now you can connect these wires at any breaker. It doesn't matter, they're all connected with combs. You also have dedicated connectors that connect supply wire with a comb, so you don't put them under the same screw. You would be obliged to do that if these breakers are automatic. The comb barely fits here, so you should definitely use dedicated connectors. But anyway, that's the principle. Luckily there is a neater method and quicker. This is a connection module made for top-fed RCDs. So this is the RCD output side connects to this and comes out here, where you connect your breakers with a comb. This is Legrand, it works with Legrand circuit breakers because the holes are aligned, but not with other brands like Hager, where the holes wouldn't be aligned. See, this one is too much in front. But it works with all, I guess all top-fed RCDs, because the distance between the screws is the same. Like this. And now this is the RCD's output, and you simply connect that output to the breakers with a comb. Now this one is quite different. You connect your incoming live and neutral conductors at the top, but where's the output? It's actually on the back, through these two plug-on contacts. You can't connect those directly to any breaker, because this RCD is part of Schneider's plug-on distribution system. Instead, both the RCD and the breakers clip onto this distribution rail. Once they're clipped into place, the RCD feeds power into the rail and the breakers automatically receive their supply from it. I can't actually install this system on this panel because it requires a dedicated mounting rail. As this addition, you see, this is a standard DIN rail. And this is the addition. The distribution rail clips onto this specially designed DIN rail, so if you want to use this system, you also need a matching Schneider panel. By the way, if you're wondering why these parts have different names, Merlin-Gerin originally developed this system before becoming part of Schneider Electric. Similar plug-on systems also exist in North America, although the designs differ between manufacturers such as Square D, Eaton, Siemens and others. As I mentioned and shown in the previous video, in most countries only the live conductor passes through the breaker. The neutral conductors don't. After leaving the RCD, all the neutrals are connected together on a neutral bus bar. So let's convert our panel to that arrangement. Here I have some cheap single pole breakers. I bought them for demonstration purposes because we don't normally use single pole breakers here in France. We'll keep using this RCD, the top-fed one, but we'll remove the distribution module because the comb won't line up with these breakers. First I'll remove all the breakers. I numbered all the outgoing circuits earlier, so we know exactly where everything goes. Clip the new breakers into place. or you remove this module. Take a comb of appropriate length. Connect the live output from the RCD to the comb. Use the wire from before. Now connect the neutral output from the RCD to the neutral bus bar. Okay, now we connect all the outgoing lives to the output of the breakers. These breakers are not of a proper size because this is for demonstration purposes only. It's okay, psychopath. Now connect all the outgoing neutrals to the neutral bus bar. It doesn't matter which order because it's a bus bar. And that's it. Almost the same thing, only the neutrals don't go through the breakers. Alright, we're almost finished. I'm just going to show you a couple of more variations. Depending on the country, on the manufacturer mostly, the supply can enter the breakers from the bottom instead of the top, with the outgoing circuits being connected to the top. We don't touch the neutrals, we don't touch connections on the RCD, we only inverse this and this. So outgoing conductors at the top, and now our RCD is output live to one of the breakers. So now power enters RCD here, exits here, the neutral goes to the neutral bus bar with all the other neutrals, the live goes here to the breakers, get distributed by a comb with all the breakers, to all the breakers, and here are the outgoing circuits. Don't let this inverse arrangement confuse you. The breakers will still be off in a down position and on in an up position. The RCD can just as easily be installed on the right hand side with the breakers on the left. Just move it. In that case, the circuit numbering usually runs from right to left. Very common in Arabic-speaking countries because they read from right to left. Just kidding, nothing to do with that. In North America, the breakers are typically arranged in two vertical columns because of the split-phase supply. I haven't seen one arranged diagonally yet, but I wouldn't be surprised if someone has done it. Anyway, I hope this video has shown you that although residential breaker panels can look very different, the underlying wiring principles are remarkably similar. The equipment changes, the layout changes, but the logic stays the same. Of course, there are many other variations, split-phase systems, three-phase systems, RCBOs, where RCD protection is integrated into each circuit breaker, so there is no need for a separate upstream RCD. When I get hold of the equipment, I'd like to cover those in future videos. For now, thanks for watching, like and subscribe, and see you in the next one.